So in this video, I want to go through Euler's method on the TI-84. So this is the example they do in Cognity. So if we click on TI-84 Plus and just follow these instructions, which I'm going to show you how to do with a different example, just so you can see it again in action. It's a little bit complicated, but once you get the hang of it, if you do enough of them, it's pretty easy. And then they also show you how to graph the solution curve, which is even more complicated and I think a little bit unnecessary to even get. You shouldn't really need to do that. So I'm going to do this section question number 1 just so you have another example of how to see the differences and where to plug things in. So the first thing you have to do is go to the mode and change from function mode to sequence mode. And then when you go to y equals, the whole screen is different now. And then we have to go up and do the sequence n plus 1. And unfortunately on the other calculators, they don't have this type up at the top. So you're not going to be able to do this on the TI-84 that isn't this version. And so that's going to be a pretty tedious calculation for you then. But you just have to use the formula. So for this problem, we're given, this is our differential equation, dy dx equals x times y. And the first thing I usually do is this y1 equals 0.5. That means when x is 1, y is 0.5. So that's u is the x and v is the y. So we want u of n plus 1 to be, we have to make this be u of x. So I have to do second, and the u is right there. And this is just following the formula of Euler's formula. That says do x0 plus the step size. So I have to figure out what's the step size. It says 0.1. So I need to do x sub 0 plus the step size. Okay, and that's all you have to do for that line. And now this 0, these are the x values. So u of 0, if we go back, it says x, when x is 1, y is 0.5. So when x is 1, the x goes there and the y goes here. Y is 0.5. So that's where the initial condition goes. The u of 0 and the v of 0, those are the initial conditions. So that x coordinate is the 1 and the y is the 0.5. So that's where that goes. And then here's the part where the differential equation has to come in. So we do v, and the v is on the 8. So v of n, and then plus the step size, which is 0.1. And then we have to do times the formula that we're given, which is the differential equation formula. So just the xy part. So we have to do, x is u of n. So we have to do times u of n. And then we're doing x times y. So we have to do times v of n. V of n, and then close the parentheses. And that's it. We have everything entered. And now we just have to go to the table, second table, and it will do all the calculations for us. And we just want to know, it says, use Euler's method to estimate y of 1.5. So we go to where the x coordinate is 1.5, which is right here. And we see that the v value is 0.8808. So we should round that 3 sig figs and get 0.881. And that's what the answer is, 0.881. And then they just give you the same table in this form. So I can do another one with you in another video.